are going to start 2.1 today, where we have our learning target that we will be able to simplify, multiply, divide, and rationalize radicals. We are going to be able to do kind of this first one. This second one we may leave for next class period. So let's get some vocabulary, some different definitions out of the way. A radical, when I say radical, that means the square root symbol.
Are you writing the math right now?
No, I have a drawing tablet that I use during remote learning. So when you see kind of the square root symbol, sometimes we refer to it as a radical.
What's radical?
A radicand is the stuff inside the radical. So the number, variable, expression, whatever we end up having in there is inside the radical, or underneath, we'll say underneath. Ooh. So the radicand is this stuff in here. So perfect squares, I know we defined it on the previous page. Anybody want to remind me what is a perfect square?
You get a whole number when you
Yep, you get a whole number when you take the square root of it. Let's go ahead and jump into simplifying. So when I simplify radicals, we always want to write them in their simplest form. In order to simplify, we should have no perfect squares in the radicand.
I'm not doing more than this. Actually, this has to be after school. And after
And one thing, the world comes to an end if there are any radicals in your denominator. So we cannot have any square roots in the denominator. We have to get rid of them. It is the bottom part of the fraction. That is correct. That is correct. So the product property is the first one listed there. I want everybody to simplify A, B, and C on your own. We just went through some of this practice together. So we can break apart a radical, a square root, into its products, the square root of A times the square root of B. So we did this before. Simplify A, B, and C all on your own.
Oh, I know. You get 5, 2. You get 5, 2. Will, what'd you get? 16. I got 5. That's 8. What's 48? 16 doesn't do it. What? Maybe get your break calculator. Actually, I don't break it. Yeah, actually, I just do make it. 18, isn't that like a special one? No, 16. Wait, what the heck? 10 to the square root of 6x. Will, did you see? Yeah, I saw it. I'm slightly here. I'm on it. How do we find it? I just asked his house was like barbecue.
All right, let's talk about letter D. Let's get all the chit chat to stop. If I was in the front of the room, this wouldn't be happening. So how do we take the square root of variables? How do we figure this out? Okay, let's think about the square root of 16 for a second. That is the square root of 4 times 4. Do we agree? So what a square root does, it says what thing times itself will give you that number under the radical. So I have 2 4s under here. The square root of 16 is just 1 4. When I take the square root of a number, we don't even realize this, but there is a little implied 2 that is part of the square root, that is just outside the radicand. So what you need is 2 of something to be able to take 1 out. So when I look, say I have just the square root of x squared. That is x times x. Since I have 2 under the radical, 1 comes out. So the square root of x squared is just x. So any thoughts on what the square root of x to the 4th would be? X squared. Perfect. So we've already simplified that part. All of that is going to come out of the radical. We will get a lot more practice with this as we go through this unit. But let's go ahead and simplify the square root of 24. We've got to simplify that as well. I get 5 times 2 times x squared, and that square root of 6 is still just stuck under there. I get 10x squared square root of 6. So as long as I have 2 of them, Will, 1 can come out. If I end up having more, and like I said, we will do a lot more examples with this as we kind of go through this unit. What happens if I have an x to the 5th or an x to the 7th?
I don't know.
All right, let's look at a couple of other things that I wanted us to get through today. We're going to do multiplying and dividing. So when I multiply radicals, I'm going to multiply the outsides with the outsides. And the insides, or the radicands, with the insides. Then simplify if possible. Bless you. All right, so let's look at our first example. I am multiplying these two things, so I'm going to multiply my outsides with my outsides. 3 times 2 is 6. My insides with my insides, and they're going to stay in the radical because they started inside the radical. So I get 6 times the square root of 30. Are there any perfect squares that divide into 30? Nope. That is as simplified as it gets. So part of being able to simplify square roots is being confident that sometimes we cannot simplify them anymore. All right, let's try our next one. I'm going to multiply my outsides with my outsides, my insides with my insides, and then see, can I simplify the square root of 24? Yes. 4 and 6, that's correct. So I wind up with 20 times the square root of 6. Right, next example. If there is no number outside of the radical, it is implied that there is a 1 there. So you're really multiplying 4 times 1, and then 7 times 7 under the radical, square root of 49. which is just 7. 4 times 7, my answer is 28.
I like more about exponent. We did non-exponent. Oh no, I have no idea what the rules are.
Good to know, Aiden. Once we get to exponents, I'll make sure we slow down a bit. All right, let's look at letter D. What does this squared on top here mean? What does that mean? I multiply it by itself 2 times. So I do 4 square root of 3 times 4 square root of 3. That's what that means. I'm going to multiply my outsides with my outsides, insides with my insides. That is correct. 16 times 3. Did anybody see a pattern in those last 2 examples that we did?
They're nice.
We ended up with perfect squares. Why did we end up with perfect squares? Because we were multiplying by the same thing. So down here I have a little note. The square root of a times the square root of a is the square root of a squared, which is just a. Can we start taking that shortcut? What is the square root of 5 times the square root of 5? 5. So is that a shortcut we all feel confident we can make in here? If for some reason, right, as we start next lecture and we've kind of forgotten that rule, I will remind us. But that is a nice shortcut, a pattern of using radicals to be able to shorten the process. All right, let's go ahead and divide. When you divide radicals, I recommend you separate or condense your radicals to simplify. And you won't really know which one you need to do. It will depend on the question. So sometimes you'll want to condense your radicals, and sometimes you'll want to kind of separate or expand them out. It just depends. I wish there was a better answer for that, but it really just depends. So what do I mean by separate or condense? Say I have a fraction under the radical like this. I could separate it out as the square root of a over the square root of b. If I have a square root over a square root, I could condense it down to one big square root with a fraction underneath. So this is an example of separating out. This is an example of condensing down. So when I look at my first example here, do I want to pick up my calculator and do 25 divided by 9? No, right? We would like to, let's separate this out. So I'm going to separate this into the square root of 25 divided by the square root of 9. Now I can simplify each of those. The square root of 25 is just 5. Square root of 9 is just 3. I have simplified this down.
My mind is gone.
So when you simplify them, the square root goes away.
What is the square root of 25?
Or not the square root.
Because the square root of 25 is just whole number 5. That's why I always worry about the trees. We're like forgetting the importance of what square root means. The square root is saying what number times itself gives me this number under the radical. All right, let's look at letter B. I've got some multiplication going on here. So let's multiply. Do we remember how to multiply fractions? No. You simply multiply your numerators, multiply your denominators. We can. We definitely can. There's a bunch of different ways to solve this, Will. You didn't have to do that. You could have simplified first and then multiplied. I was trying to pick the shortest way possible. So I have now the square root of 12 over 100. I am going to separate that out to the square root of 12 over the square root of 100. I get 10 on the bottom. I have a square root of 4 times the square root of 3 up top. 2 square root of 3 over 10. Maybe this wasn't the shortest way.
I mean, you can shorten the 4 immediately.
Yes, you can shorten the 4 immediately. I get the square root of 3 over 5.
Wait, what?
What's the square root of 4?
Square root of 5.
There.
How the heck did you get square root of 3?
So once I get down to the end, all the stuff that's outside the radical, that's just a fraction. I just simplified 2/10 down to 1/5. All right, we'll let letter C be the last thing we do today. So here's an example of where it's already separated. It would be kind of nice to just condense it down to one fraction. Why? Because what's 20 divided by 5?
4.
And what's the square root of 4?
2.
There we go. Now, when you looked at this example, when we started this example, does the square root of 20 divided by the square root of 5 necessarily look like 2? It's hard to know when you're simplifying what the answer is going to be unless you go through and use some of these steps.